I am now going to walk you through, these are the ones from Delta Math, of the graphical kind for limits and determining continuity. So in this case, they start exactly where my diagram started, which I will, I actually don't really need to pull it up because Delta Math takes my diagram and walks you through it step by step. So they're looking for x equals -2, which if you wanted to annotate it, that's located here. So from the left of -2, that means you're going to trace the graph coming from the left side. Follow the line to the left side. You're going to land at -4. For the right limit, you trace the line and you also land right there at -4. So my left limit is -4 and my right limit is also -4. I'm just connecting my keyboard. So left limit is -4 and the right limit is also equal to -4. So since the left and the right limits are equal, we know the limit is going to exist and be equal to the same exact value of -4. And then our y value in -4 is going to, in -2, is also going to be -4 because if you look at the graph, let me clear all drawings. There is no open circle or anything at -4. So f of -2 is also -4. So my limit exists and my limit equals my y value. So I'm continuous because the limit as I approach -2 is equal to f of -2. And as you can see, Delta Math is slowly tracing to show you the limit from the left and is about to do the limit from the right. Remember, for limits, graphically, you're going to follow the line and only the line. This one says x equals -5, but I'm going to skip this one and find a different one because that one's similar to the last one. Okay. This one is x equals 3. So I always say, or at least I always do this in class, x equals 3 would be here. So let's check. 3 from the left, you're tracing the curve coming from the left, the line coming from the left of 3. So a line from the left on 3, you land at 2. When you're coming from the right side, you land at 0. You're looking at the y value. So on the left, it's 2. On the right, it's 0. So what that says is my left and my right are not the same. So because my left and my right are not the same, my limit does not exist. And now let's look for my y value when x equals 3. Remember, for f of 3, you want the closed circle, which in equation land is the or equal to. So the closed circle for x equals 3 is on the x-axis when y is equal to 0. So because the 3 numbers that I found are not the same, I am not continuous. And if it makes sense in your brain and you can automatically see it, x equals 3 is a jump discontinuity. But we know we are not continuous because the limit does not exist. Dun, da, da, da. Look at us go. Being amazing. Oops. Clear all my drawings. And let's try another problem. This one says x equals -1. So let's do it. From the left of -1, trace the graph, which means the line coming from the left side of -1. So for annotation's sake, for x equals -1, you can either draw the circle like I've been doing, or draw like a vertical line through x equals -1. It's whatever works best for your brain in visualizing this. So from the left, when you trace the graph, you land on the vertical line at y equals -4. From the right, when you trace the graph, and here we go. No. I need my, okay, it's still recording. From the left, when you trace, you land at -4. From the right, when you trace, you land at -2. So the left is -4, the right is -2. So because those two are not the same, our limit does not exist. So because our limit does not exist, we look for the y value. Well, you have to check that anyway. Okay, the limit does not exist, so that just tells you off the jump it's a jump discontinuity. But to check the y value, you look for the closed circle. There is none. So you could either say f of -1 is you could say undefined or it doesn't exist. But we're not continuous because the limit does not exist. And I sort of feel like they're gonna, yep, here we go. You see how they trace it limit-wise from the left and the right? And they do not meet up, the purple and the green. Awesome sauce. This one's asking for x equals 0. For some reason, I want to find a nice example here. This one says for x equals -3, but I just want to show you something at x equals 3 for this, so you can get used to seeing it on a graph. X equals 3 is here. So as you can see, there are, oh, my annotation was still there. There are two arrows that are pointing down, which says, as I approach +3 from the left, I'm going down to -infinity. As I approach +3 from the right, I'm going down to -infinity. Note how I never actually touch x equals 3. So me having arrows near x equals 3, but not touching x equals 3, tells us that at x equals 3, there is a vertical asymptote. Emphasis on the vertical asymptote. So because there is a vertical asymptote, there is an infinite discontinuity. Same thing here for x equals -1. Both arrows are going down to -infinity. So your limit on the left is -infinity. Your limit on the right is -infinity. So that means there is a vertical asymptote, which means infinite discontinuity. And I'm going to find now some examples of like limits because some people struggle with finding limits from a graph. One-sided, two-sided, all of that. So this one here says, find the limit as x approaches 1 from the left. So here's x equals 1. You can literally just draw a vertical line through it. And now, to trace it from the left, follow the line from coming on the left and see what the y value you land on is. You land at 5. So my limit as x approaches 1 from the left is going to be equal to 5. On this one, it says -3 from the left. So you find -3, which is this line here where the two circles are open and closed, come from the left side, which means like from -4, making your way closer to -3, and you see that the y value is equal to 4. This one says x approaches -2 from the left, but where are the, here we go. This one says 4 from the right. So here's x equals 4. There are two open circles. And remember, limits do not care about open versus closed. Limits just say, where are you on the graph? What is the y value when you get there? Open circles are for if you're saying the y value technically doesn't exist. Like you can plot it for limit's sake. You can plot the circle and that's your answer, but there is no actual value there. So from the right to 4, so you're coming from like 5, 6, 7, working your way back to 4, you land at -2. And they're tracing it on the delta math graph in green. But let me go back and look for, let's see if this one works. Yes, this is magicalness. Okay. So looking for, that one's an easy one. This one, okay. They said -2. So x equals -2 is this right here. You see an open circle at x equals -2, so that automatically tells you that your y value doesn't exist. So f -2 doesn't exist. So now you check from the left. The left of -2, you land at y equals 3. From the right, you also land at y equals 3. The left limit and right limit are 3, which means two-sided limit is 3, and my value does not exist, as you can see from the tracing of the graph. This one says x equals -5. So you're on this vertical line here through the x-axis of -5. From the left, when you trace it, you land at 6. From the right, when you trace it, you land at 1. The left is 6, right is 1, so that means two-sided. Because 6 does not equal 1, my limit does not exist. And because there is not a closed circle, my value does not exist. For x equals -5 here, I draw my vertical line. You can use a pencil or like stick your finger, something, so that you can like see what's there. From the left, you land at -1. From the right, you land at -4, which means two-sided limit does not exist. And for the y value, look for the closed circle, which is at a y value of -1. See, let them trace it. Left, you land at a y value of -1. On the right, you're going to land at a y value of -4. And let me see if there's one more topic-y thing. Okay. So this one, which did confuse a lot of people when I gave it to you a little while ago, it says, find all values of a where the limit is equal to -2. So what that means is, my tip for this. Draw the horizontal line through y equals -2. And you're looking for these spots where the graph has, it's either the graph is just like gonna like connect straight through, or it's gonna have something that connects, or like a circle, graph, graph, or a closed circle, graph, graph going through it. So if we're here, assume that line is straight. We have one value here at -6. There's one value here at 0. And if you look here, it does not work because there is a jump discontinuity and only the right limit at 5. So x approaches 5 from the right, the limit, that's -2. From the left is -6. So your answer to this is -6 and 0. So -6, comma, 0. Which oops. Oh, it is 1 because, yeah, this sort of thing happens sometimes. Math teachers make mistakes too. It's actually 1. You have to like really zoom in to like see it. Because 0 is like a little under the -2. Okay. This one says same thing. Where is the limit equal to -2? So draw your horizontal line and x equals -5. A equals -5 does not work. That one's out. 1 does not work. 5 does not work. So what that says is the answer to this is the empty set, which would be there's nothing. And that's how you write the empty set in math. This one says same thing. When am I gonna get a new? Here we go. I want to find a good one. Okay. This one says, where is the limit as x approaches a equal to 0? Find all values of a. So y value of 0 means x-axis. So looking on the x-axis, you see you have this value of x, that one, and that one. And you want to see the one that has both sides of the line meeting up at 0. So -6 doesn't do that. Yes, you want both sides of the line. No, did it stop recording? No, it didn't stop recording. It just, my tablet's being annoying. So you want both sides of the line meeting up at 0. Didn't happen at -6. It didn't happen at 0. It happens at x or a is equal to 1. And it does not happen at 5. So the answer is just 1. Final problem of the day. You want the limit as x approaches a equal to 4. So what that says is you want to find the spot where both sides of the graph at that x value will meet up at a y value of 4. So y value of 4 happens here at x equals -7, but both sides don't meet up. It happens here at x equals -1, which has 2 lines that meet up. So -1 is one of them. Let's see if there's any more of them. It happens at 0. It meets up at the y value of 4, but both sides don't meet. And it also happens at 6, which has a y value of 4, but both sides don't meet up. So the only answer is -1. And as your math teacher, I would just like to say, I will see you in class tomorrow.